Alright, so next topic is 5.7 data encryption and cryptography. Very important from exam point of view. But before starting with 5.7, we will discuss some questions from the earlier topic. Alright, let's look at question number 1. An IS auditor examining a biometric user authentication system establishes the existence of a control weakness that would allow an unauthorized individual to update the centralized database on the server that is used to store biometric templates, often following of the following, which is the best control against the risk. Point number A, Kerberos. Point number B, vitality detection. Point number C, multi-modal biometrics. Point number D, before image after image logging. The correct answer is Kerberos. Alright, let's look at the next question. So the thing is that they will not ask you something difficult. Alright, difficult from this topic, SSO or Kerberos. Alright, the question will be easy, but you are supposed to understand where to apply which concept. Alright, because here the question was about authentication system. Alright, so you must understand where to apply which concept. Let's look at the next question. Question number 2. The most effective method to ensure that only authorized users can connect to the system is: point number A, a complete password requirement. Point number B, SSO. Point number C, two-factor authentication. Point number D, IP restrictions. The correct option is point number C, two-factor authentication. Alright, because see, complex password requirement, it is what? Single factor. SSO, again single factor. Alright, single login ID and password. Two-factor authentication is much more what? Effective than one-factor authentication. So the correct option is point number C. Alright, they also have some few questions, like for example, major risk in case of SSO. Major risk in case of single sign-on is unauthorized password disclosure. Alright, single sign-on risk, unauthorized what? Password disclosure. Best recommendation in case of SSO, again strong password policy. Advantage of SSO, password management process is easier as compared to multiple passwords. Alright, we have discussed in SSO that password management is quite easy in case of SSO. So let's start with the next topic, 5.7 data encryption and cryptography. Very important topic. Alright, and you can say the most complicated topic in domain number 5. Important from exam point of view, and slightly complicated to understand things. So we will go very slowly and we will look at 5.7 very deeply with practical examples as well. Alright, so let's start. Now, there is a sender, there is a receiver. There is a sender, there is a receiver. The sender is transmitting some data, but now the data is in plain text. The data is not in encrypted form. Alright, for example, the data is in the form of plain text. For example, the data is passed CISA. I have passed CISA. Now this plain text is converted into ciphertext in case of encryption. So when we say we have encrypted the data, basically we have changed the plain text or plain data into cipher data or ciphertext. So as you can look in the screen, just wait a second. Yes, so these letters passed CISA is converted into @ this 8 UP6 AN. Alright, so basically this plain text is converted into something which you cannot understand by looking at it. Alright, it is called what? Ciphertext. So plain text is converted into ciphertext, so that even if someone tries to access, someone tries to look at the data, they will not be able to understand what exactly is the information. So in case of this entire data encryption, the sender the sender you know the sender converts the plain text. The sender convert the plain text into ciphertext. Just wait a second. Yes, the sender convert the plain text, all right, encrypts the plain text into the ciphertext, all right. Now the receiver receives the ciphertext, and now the receiver will decrypt the ciphertext to get the original text. So plain text is encrypted and then it is decrypted by the receiver. All right, let's look at this image. So as you can look at this image, the plain text is converted into ciphertext. All right, but during encryption and during decryption, again converting ciphertext into plain text. So while encryption and while decryption, same key is used. While encryption and while decryption, same key is used. Same key is used. All right, same key is used in case of encryption as well as in case of decryption. So whenever same key is used, it is called as symmetric encryption. Whenever same key is used for encryption as well as decryption, it is called as symmetric encryption. Don't worry, even if you do not understand it right now, all right, you will definitely understand. Have patience. There are many things to discuss in this particular topic. All right, so have patience. You will understand each and everything by the end of the session. So in case of symmetric encryption, same key is used, but in case of asymmetric encryption, different keys is used. All right, for encryption we have used public key, and for decryption we are using private key. So again, same thing is happening. Original text is converted into ciphertext, and then again ciphertext is converted into the original text. But over here we are not using same key, we are using different key. The sender is using different key, the receiver is using different key. All right, so public key and private key. Let's proceed ahead. Yes, so there are two things we have discussed. We have discussed about symmetric key cryptography and asymmetric key cryptography. All right, so till now what we have discussed that the sender is converting the plain text into ciphertext. All right, so encryption and decryption is happening, and whenever same key is used for encryption and decryption, it is called as symmetric encryption, and whenever different keys are used, it is called as asymmetric encryption. All right, now let's proceed ahead. Very soon we will also look at one practical example also. So don't worry, even if you do not understand anything, all right, we will also look at one practical example. So we are starting with the asymmetric key cryptography. So there is a sender and then there is a receiver. There is a sender, there is a receiver. Sender is having public key and private key. Receiver is also having public key and private key. So there are two keys, public key and private key. Sender is also having public key and private key. Receiver is also having his own public key as well as the private key. So we can say we are looking at four keys: sender's public key, sender's private key, receiver's public key, receiver's private key. All right, so what exactly is this public key and private key? Just wait a second. Yes, so in cryptography, a public key is a large numerical value that is used to encrypt data. The key can be generated by a software program, but more often it is provided by a trusted designated authority and made available to everyone through a publicly accessible repository or directory. All right, so public key, as the name itself tells you, it is freely available with each and everyone, with the general public. Anyone can access that key of a particular person. So public key is available with everyone. Public key is publicly available. So in case of this diagram, the sender's public key is available with the public, but the sender's private key, again the name itself tells you, private key, it is totally private. The sender's private key is not available with anyone, not even the receiver. Even the receiver do not know the sender's private key. Sender's private key is only with the sender. Even the receiver do not know anything about the sender's private key. No one knows about the sender's private key except for the sender. Similarly, receiver's public key is available with the public. Anyone can get that particular key, but receiver's private key is not available even with the sender. Receiver's private key is fully private. All right, no one has the access to this particular key. Only receiver knows his private key, no one else, not even the sender. All right, so till now what we have discussed, there is a sender, there is a receiver. Sender is having sender's public key, sender's private key, receiver's public key, receiver's private key. All right, public key can be easily be availed by anyone, but private key, sender's private key, is only available with the sender. Receiver's public key again can be easily be availed by anyone, any public, but receiver's private key is only the receiver knows about it. Not even the sender knows about it. All right, so let's look at the basic process. Again, this is not the entire process, all right, but we are just starting with the concept. So there is encryption and then there is decryption. Now you can encrypt using sender's public key, and then you will have to decrypt with sender's private key. But if you use receiver's public key for encryption, you will have to use receiver's private key for decryption. All right, so encryption, there can be different permutation and combinations available. There can be different permutations and combinations available. You can encrypt a particular data using sender's public key. If you are using sender's public key for encryption, you will have to use sender's private key for decryption. And if you are encrypting the data using receiver's public key, you will have to use receiver's private key to decrypt the data. Now this thing can also be opposite. I mean, you can encrypt using the sender's private key, and in that case you will have to decrypt using sender's public key. You can encrypt using receiver's private key, and in that case you will have to decrypt using receiver's public key. So there are different permutation combination. All right, let's proceed our discussion. So as you can see in the screen, there is a sender. Now obviously sender is supposed to encrypt, because sender is someone who is sending the data. Sender is someone who is sending the data to the receiver. So sender is supposed to encrypt and receiver is supposed to decrypt. Sender is supposed to encrypt and receiver is supposed to decrypt. All right, so understand that the sender can use sender's public key for encryption, and if the sender is using sender's public key for encryption, he is supposed to use his private key for decryption. Alright, but understand that decryption will be done by the receiver. Decryption will be done by the receiver, and receiver will not have the access to sender's private key. Receiver has receiver's private key. Receiver is not having sender's private key. But in case of this permutation, in case of this combination, we are saying that encryption by sender's public key and decryption by sender's private key. But the receiver is not having the access to the sender's private key. Just now we have discussed that only sender will have the access to his own private key. Receiver has access to his private key, receiver's private key. Receiver do not have access to sender's private key. Alright, receivers do not know about the sender's private key. So in that case, this combination is not working. But is it possible to encrypt and decrypt? Yes. Yes. But this combination is not working. Alright. Next combination is encryption using sender's private key. And then the receiver will decrypt using sender's public key. Alright. This is the next combination. But again, understand that if sender is encrypting using sender's private key, alright, in that case, anyone from the public can decrypt that information, can decrypt that data, because sender's public key is available publicly. Just now again we have discussed the public key, as the name itself tells you, publicly available. Anyone can get that particular key. So if the encryption is done using sender's private key, in that case it is supposed to be decrypted using sender's public key, but sender's public key is freely available. So in that case anyone can decrypt that data, and this is not something we want. We want protection of the data. We don't want anyone to get the access. So this is not something which will work. Alright, so even this combination is not working. Let's look at the next combination. Receiver's private key and receiver's public key. Now over here, the sender is encrypting the data using receiver's private key. What? Private key of the receiver. Again, sender will not have the access to receiver's private key. Sender knows only about his private key, sender's private key, not receiver's private key. So in the third combination, we are saying that encrypting using receiver's private key, but sender is not having what? Receiver's private key. So again, even this combination will not work. So till now we have seen 3 combinations, and all the 3 is not working. All the 3 combination is not working. Let's look at the 4th combination. The 4th combination is sender is encrypting the data using receiver's public key. Can the sender have receiver's public key? Yes. Yes. Receiver's publicly available key. So sender can get the receiver's public key. So this is working. Now the receiver will decrypt that particular data using receivers. This time receivers his own private key. Yes. Now this combination is exactly working. This combination is exactly working. Alright, over here we are encrypting the data. The sender is encrypting the data using receiver's public key, and when the ciphertext will be received by the receiver will decrypt that ciphertext using his own receiver's private key. Now this combination is working. Alright, now let's look at one practical example to understand this entire whole thing. Whatever we have learned till now, we will look at one practical example. Now there are two screens in front of you. All right, let's assume that this first one is sender's computer, and this second window is receiver's computer. For time being, let's imagine that I have divided the entire my screen into two parts. Let's assume the first part belongs to sender's computer and the second part is receiver's computer. All right, now we are generating keys. All right, so the sender is clicking on generate keys. All right, and now the receiver will also click, but wait a second. All right, the sender has just generated public key as well as the private key. All right, now let's copy this key, copy, and let's say for example the sender is Aditya and receiver is John. I am the sender Aditya and receiver is the John. So Aditya's computer. All right, let's save this public key. This is public key. All right, so basically I am saving this public key. All right, now there is also private key. So the sender has generated both public key as well as the private key. So I am also saving my private key. The sender Aditya is saving his private key. All right, so basically Aditya has saved his public key as well as the private key. Now I am generating keys for the receiver, for Mr. John. Now this is John's computer. John is also clicking on generate keys. All right, now John is saving his keys. Control C. John's computer. Now this is John's public key. All right, paste, save. All right, now John will also save his private key. Yes, so this was private key of John. Copy John's private key, paste. All right, so our first task is over. All right, the sender has created his public key and private key, and the receiver also has created his public key and private key. All right, now let's start with the entire process. Now there is sender's computer and then there is receiver's computer. All right, now the sender wants to, Aditya wants to send some particular data, particular text, particular information to John. All right, so basically I am supposed to convert the plain text into ciphertext. All right, so basically now I am going over here and I am typing enter plain text. All right, let me zoom in. Just wait a second, let me zoom in. All right, so basically it is asking me to enter text, plain text to encrypt. All right, basically I am putting CISA score 625. Right, CISA score is 625. All right, now I don't want anyone to access this particular information. I am sending this particular information to John, and during the process of transmission I don't want anyone to look at this particular information, look at this particular data. So I am supposed to convert it into some form which no one can be able to identify. All right, so basically just wait a second. Yes, now Aditya is supposed to use John's public key. Sender is supposed to use receiver's public key for encrypting the data, for encryption. All right, so basically I'm going over here. All right, and John's public key. All right, John's public key, control A, control C. All right, now I do have John's public key. All right, so basically I am encrypting the data using John's public key. So I am pasting John's public key over here. All right, now I am clicking on encrypt. Let me zoom in again. Yes, so basically this is the public key of John and this is the data, CISA score 625. All right, now I'm clicking on encrypt. All right, now this ciphertext is formed. Now this is the ciphertext. All right, let me zoom out. All right, so basically again control A, copy, and then ciphertext. Just wait a second. Yes, now we are creating a new file, ciphertext. All right, control V, file, save. Yes, so basically now ciphertext is formed. Now I will send this particular ciphertext to Mr. John, so that even if someone has the access, they will not be able to understand anything. All right, so ciphertext is formed. Now we are coming to John's computer. Now John has just received the ciphertext. Now John is supposed to decrypt that ciphertext to get the original information. All right, so now I'm coming over here. All right, now basically I am pasting that ciphertext on John's computer. Now John will put the ciphertext. All right, now I am going to John's computer and now John is putting the ciphertext. Right, so basically John has received the ciphertext from Aditya. All right, he's opening the file. All right, control A, control V. Right, copy. Yes, so basically now John is putting the information over here. Let me zoom in again. All right, so basically on this particular area they are asking about enter plain text to encrypt, but John doesn't want to encrypt. John wants to decrypt. All right, so John will paste now here, enter encrypted text to decrypt. Now here John will paste. All right, now basically John has pasted the encrypted text over here. Now John also require his private key. All right, John will require his private key to decrypt that particular data, because this encryption was done using John's public key. Aditya has used John's public key to encrypt the data, so John is supposed to use his private key to decrypt the data. Alright, let me zoom out. Now I'm going over here, John's computer. Now John is opening John's private key file. Alright, Control A, Control C. Alright, now John is pasting his private key over here. Now let me zoom in. Alright, so basically we are in John's computer and John has put his private key and John has put the encrypted data ciphertext. Alright, now John will click on, just wait a second. Now John will click on decrypt button. Alright, now he has got the information CISA score 625. Alright, and no one was able to access this information. I mean, even if the access was there, still they are not able to identify what exactly was the particular text, because it was in the form of ciphertext. Alright, let me zoom out again. Basically this was the entire journey, alright, of the data transmission from Aditya's computer to John's computer. So whatever we have discussed previously, I have just tried to explain you practically, so that all things get into your mind. Alright, but the discussion is not yet over. There are many more things to discuss.